Right. Cool. So we are broadcasting now. I'll open the Discord to see what the complaints were about the broadcast not being there. Yeah. Yeah. Okay. Yeah. Okay. Sorry about that. That's really like fleeting face. Okay. Anyway, so forgot about that. So that's good. Hi, Discord. Okay, I think they see me. Okay. So we're going back to just what C programs look like, and I wanted to point one thing out, which is we made a big deal about compiled versus interpreted languages, right? And as far as we know, like if you look at this interface, nothing really changed, right? This is still running whatever program this is, just line by line. That is a simulation. So in a way, what's going on there is and they are treating it as an intern. It's a little bit once we move to VS Code, which we'll do on Friday in lecture, and in the lab you'll start practicing with VS Code. There would be a separate step where you actually compile the code. And compile just means take the C code and translate it using the compiler program into something that the computer can run directly. So, okay. Okay. What are people saying? What has been 3 years ago? Yeah, I don't know. Yeah, okay, all right. I have been teaching this course for a while. But I have changed the format. So the updated thing is still where it was last lecture. So, okay. So this is just an overview of the kind of variable declarations that we have seen, right? So the way it goes is you have a type. So the type might be int. The type in this case might be long int. So you can have types that are two, tokens. So the reason I brought this up is that in C, if you want a long int, which essentially means this is a little bit computer dependent, but an int that can contain more digits than just the usual int, you define it like that. Notice the big L at the end there. So that is how you input a long int. You don't really need it for this course. This is just like something that you would sometimes see. So here the type is car, and what we're doing is we are assigning the literal single quotes at sign to C. So the language C makes a distinction between characters and strings. So this would be a character. By the way, this is how you make comments. And that means a single character. This is string. So I put string in quotes because it's not really a string as such. What it really is the address of the first character in the sequence. A, then B, and D, and then no. So what's stored in memory really is characters, like the S sign, like A and B and C, and then C, the programming language, provides you a shorthand for this is S actually, which is good. So this is the shorthand for A and then B and then S and L memory, and then put this guy lives in the left side. So is written like this. Like this, and our textbook was written by Brian Kernighan, actually one of the most famous Shanghai grads. So I think like 60, I forget, but 62 or something like that. It's pretty old. But there is this thing called Kernighan and Ritchie style, named after Shanghai grad Kernighan, so we're doing it like that. So for that reason, we write things like this, and it's just a matter of style. So this is the type. So car star is the type. Some people prefer to write it like this. As far as C is concerned, it's the same. The idea would be that this suggests that it's the car star that's the type, and then S is the name. But really, they're the same. Okay. Another way to assign to car star is to do something like this. So if you remember, ampersand, so this is like the and sign is called the ampersand. And that means address of. Okay. And what we're doing here is we're saying, get me the location where C decided to store this variable C, and put the location, meaning the address, in the variable PC. So PC will become this number. So let's just run all of that in Python Tutor. I was wondering where the args were. Okay. So in C, unlike in Python, I cannot just have standalone code. It has to be inside the function. And if it's just the one function, it's a function that's going to be named name. So what I have done now is optional. Indentation is optional. Like we said, what really indicates that it's the body of the function is the fact that it's enclosed in curly braces after the function header has been declared. To remind you, the function header is we're returning a variable of type int, a value of type int. This is the name of the function, and this says that this particular function doesn't take parameters. So because we said that we'd return int, I'll say return 0 over here. Okay, so let me visualize the execution. It's not happy about this, so this is just copied from PowerPoint. So I just need straight quotes over here, as opposed to kind of the curly quotes that you get in PowerPoint. So now it's good. I will switch to show memory addresses. And this is just so that we see what the process here is. Okay, so this is just this tab. This is about the user and interface for Python Tutor. All right. So unlike with Python, there is no variable table. What there is just C pre-decides when the function is run, where each variable is going to be stored. So those are addresses. The addresses are written as what's called hexadecimal notation. So this is basically a system where instead of just having the digits 0 through 9, you have the digits 0 through 9, and then also digits A, B, C, D, E. So that's convenient for some things, inconvenient for us for our purposes right now. So what you need to know is those are numbers. They're just like weird ordinary numbers, but written in weird notation with 16 rather than the usual 10 digits. Yeah.
Is that a Python thing or C
thing? It's neither. It's so the question was, is it a Python tutor thing or a C thing? And the answer is it's kind of difficult to tell. This is the convention of how everyone does it. At the same time, there's always a choice about how to display them. So the convention is to display in hex, but it's a choice, and we'll see this choice actually very soon when we print one of those values. Like you can print it in decimal, there's no problem. Yeah. So we'll get to the stack and the heap later on. So right now everything's on the stack. Yeah, well, I promise I'll tell you. Yeah.
So
Char star is like when you want a string, and char is just when you want a character, right?
Okay, so that's a good question that brings up interesting issues. So the question was, is it that you just use char star if you want a string, and if is it that you use char when you want a character? And the answer is it's kind of right, except char star is not exclusively for when you want strings. So we'll see more details later. And in fact, like you see an example here where PC is char star, but it's not a string. All right. So, okay. So let's just see how it goes. So basically we're running it line by line. So again, kind of what's happening is you have this, we call it frame. So in this frame, you have variables. Where they are is already pre-decided, but what the values are going to be, sometimes it's going to be preloaded for efficiency, but essentially you go line by line and you modify the value in those boxes. Okay. So, okay. So now what happened is in LA, which has, which lives in this address in the memory table, we put this value, and now we're going to put the @ sign is at C, so same as before. So now what's happening is, okay, so ABS needs to live somewhere. There's no space for it here. So the heap is, I'm a little bit unhappy about this because ABS would not always be technically on the heap. So when we talk about the heap, that's not necessarily where it's going to be. But in this case, the heap, I suppose, in the context here, just refers to anything that's not the stack. The stack is just the frame of the current local variables. So, or any frame. Anyway, this thing, like it's not, like this is not exactly what's always going on, what's shown in the picture. But the important thing is that what's shown in the picture is ABS needs to be stored somewhere. So what C has decided is to store it at address starting this. So starting, this address, and then B is at the next address, and then S is at the next address, and then the null is at the next address. And then S is going to be, this. So here it shows it as, so here it shows it like this. So this address is this address. Make sense? So, okay, so it's kind of like Python, except in a way simpler. So all of those are boxes. Some of those boxes correspond to values that happen to be addresses. In Python, everything in the variable table is addresses. Here, not everything, right? So here, this is literally 42. This is literally whatever this is. But if we say, I specifically want S to be an address somewhere in the memory table, and then I initialize it to ABS, it'll get the value of the address, and that's just going to get written here. So this is the other way in which you might use an address variable, or what's called a pointer. You could say, give me the address of C. So the address of C is just this guy, and put it in PC. Right? So the effect here is going to be taking this and just copying it over here. Okay, so that's what happened. So I think this is a lot when you're seeing it now. I guess it's technically for the second time, or like for time 1.5, I don't know. The important things here are to just do it line by line and say what could possibly happen. And the answer in C is nothing happens unless you explicitly tell it to. So what happens here is kind of the paradigmatic situation where it's just the number 42 that gets put in A. So that's straightforward. Here, you should think about it as much as possible as the same kind of thing happening. So car star is just another type of variable. It's literally a number. It's just that that number happens to be an address, right? So here it must be that if we are able to do something with this, it must be that the address that we put in S is just the address of the A. Yeah.
Car star is an integer either way. Why don't we just use scandal?
So the question was if car star is an integer, well, I should say a number either way, it's actually a long int, if anything. If car star is an integer either way, why not just use an int? And the answer is C has this, so both efficiency and nudging you towards writing more correct code. So efficiency, because if I tell C I'm only going to use C as a car, it'll know that it doesn't need to waste a lot of space on storing my car C, because that's just one character. So that's one way to say it is it's about efficiency, and more so if you know everything that's going to take, kind of how much space any variable is going to take in the program ahead of time, you can just allocate one chunk of memory and put all the variables that you need in there. That would also be more efficient. The other consideration is make things more readable. So if you remember, you can actually force it to not behave the way you would expect. So I could say like PC is like whatever, something like that, and just say, well, this is now my address, and now you could say star PC, and that means, if you remember, go to address, get the value at address PC. So the problem with this code is, if you kind of fact it like this currently would get you a warning, but you can make it run. But if you allow me to just type in addresses, that creates all sorts of issues. First of all, if I type in the wrong address, then you are essentially allowing me, without checking, because you allowed me to just like type stuff in as if it were an integer, you're allowing me to access any address. One problem would be I'm not allowed to access that address, so the program would crash. The address doesn't exist, so the program would crash. Or actually the address does exist, and I'm, a virus that's trying to maliciously steal your password, so that creates security issues. So for those reasons, C tries to make it so that apart from 0, you don't get to type in your own addresses. And one way of doing it is to make it so that when you're assigning to something like PC, assigning to something like S, that what's on the right-hand side is definitely a valid address that you're actually allowed to access. Yeah.
What if the virus program is stored at address 0?
Well, address 0 is not something that I would worry about that much. I would also not worry about programs as such. It's not like if you know the address of a virus that you can automatically run it. That's not how computers work. But it is sometimes an issue, less so these days, that you kind of try to hack your way around by. So even though you cannot directly type in an address, there are ways of trying to get an invalid address or an address you're not supposed to have, and then try and peek at where the data is there. We'll see that actually momentarily later, but that's possible in principle. All right. Yeah.
How does car
Yeah, so the question was a good time as any to discuss, although we'll come back to that later as well. So the question was, how do we know that, how does C know that star PC is a character and not, let's say, an integer? So the type of star PC is implied by the type of PC. So if PC is of type car star, meaning it's of type address of character, then when I tell C, at least by default, go there and get me the value, it'll get me a character. So this is automatically of type car unless I convert. Yes. So C could not, so this C could not be a string, right? This C, it's just, you know, this C really is a character. Now, what you're saying is like, what if it happens that the thing that's stored right in the cell after C is a character, I don't know, Z, and then after that it's null? Couldn't you happen to interpret it as a string? And the answer is yes, you could, but that's not how things work. So you could, in principle, hack your way around to doing that and force C to say, oh, I know you think it's a character, but actually treat the address of that as a string. But it's generally not a good idea. Anyway, we'll get to more of that later as well. Yeah.
Right, star PC if PC is of type char star or car star like.
So I can only write. So the question was, can you only write star PC if you said if it's of type car star? The answer is I can only do that if it's an address, right? So I cannot, for example, do something like star C. So that's an error because C is not an address.
So you could do star A.
Not star A and not something like star PC, right? Because PC is an address, so star PC is allowed, but star PC is now saying treat star PC, which is just a character, as if it were an address. So that's by default not allowed. All right. All right. So yeah.
You did star and star. Would that work?
Yes. So the question was, and again, like this is maybe getting a little bit ahead of ourselves, but why not? So the question was, what if you do something like address of C and then you like cancel it with a star essentially? Can you do that? The answer is yes. That's the same as C. Can you like address of again? Yes, you totally can. That's fine. And then you can like cancel it again. That's completely fine. With PC, if you do address of PC, which you can, this is now address of PC. So it's an address of an address, which means that you get to, this is called dereference it twice. That's completely fine. Yeah.
So, maybe car star S, it's sort of like a sequence of characters that have a address, right?
Yes. Well, I mean, it's stored in as a sequence of characters. Sequence means at subsequent addresses.
Okay, so but the addresses are like consecutive numbers, right?
The addresses are consecutive numbers.
Python it went up by like 32. Is that?
Again, this is the actual thing that's going on. In Python, for most things that are not characters, it really does usually go up by that much. Characters in C specifically take up 1 byte. So that's kind of specific to characters, actually. Yeah. Again, like we'll get to the details, but I want to give the big picture first. So I want to advance a little bit. Arrays. So arrays work like this. So an array is a sequence of objects in the same way that the list is a sequence of objects. In C, arrays are typed. So you have to say what kind of objects are in your array. You can initialize arrays like this. So you can say, I want to have an array of size 3 in this case. And the way we know that it's of size 3 is that you provide 3 elements to initialize. Okay. So that's the usual initialization. Note that this is just initialization. You cannot do this at runtime. So you cannot say something like array is equal to 1, 2, 3 because I want array at 0 to be 1, array at 1 to be 2, and so on. Yeah.
So let's say that array, so we can store integers in the array. What if you store multiple variables?
There is not really a standard way of doing it. So the question was, what if you want to have something like a list in Python where you can have heterogeneous elements? The answer is that there are tricks for doing it, but there isn't a built-in way to do it. Yeah.
Declare the array without putting anything in it and declare the size as well.
Yes, you can. So you can, rather than do this, you can also say that this would be an array of size 10. All right. So, okay. Let's use arrays for a bit. And they work really the same way as what you'd expect from Python as well. So I can say, int array. So make it like 5, 6, 7. We already had printf, which we're waiting for like the official full rundown how it works. But let's say that I want to print array at 1, something like this. 0. So here we have an array, 3 elements, 5, 6, 7. I want to print array 1 as a decimal. Okay, so array 1 was 6. So that's the array. Okay, yeah. Can arrays in C? No. So an array has to have a type. So like I said, there are tricks for trying to make it so that it's not like that, but there's not like a built-in way of having the types be heterogeneous. Yeah.
It's already works similar to the car star.
Yes, so that we'll get to that. It is quite related as it turns out. So okay. So all right, so that's arrays. And in fact, I do want to go to your question now. So just kind of to review and that's because the way we operate on arrays actually happens to have to do with how we operate on pointers. So this is the syntax for pointers. Again, kind of all there is to it, right? So if the type is int star, then what's on the right-hand side needs to be address of an integer, right? If the type over there is car star, that means that what's on the right-hand side has to be an address of a car. One way to produce an address of a car is to have a string, right? So you can go to something like this. So like go to PA. So this means get me the value at address PA. And we're saying put 43 in P8. So in practice, what it means, because PA happens to be the address of A, this is saying go to the address, which is the address of A, and put 43 there. So let's run this through. And I'll need to fix the quotes. Okay. So again, and I think that's actually a better example than before, maybe. So what we have is these boxes that correspond to variables. So we have A, and we have PA, and we have S. And initially, A is 42. So here is an interesting initialization. We're saying PA, which is of type int star, is going to be initialized as the address of A. The address of A is this guy, right? So this is where A is stored. So what we're doing is we're taking this and we're placing it over here. Okay. And I was saying before, the way to always think about those things is we're manipulating numbers, right? So here, address of A was this, and saying put this into PA just literally means that. Take the address and put it as the value into PA. So we're doing the same with S, that's fine. And now we're saying star PA equals 43. So star PA without the type means that you are what's called dereferencing. So you're saying go to address PA. So go to this address and then go to the value. So that means that when we're talking about star PA, you're talking about this guy. And what line 8 is saying is we're talking about this guy on the left-hand side, replace it with 43. So this is about to become 43. Yeah.
Wondering, you see, it's all the variables usable, so we have to use the pointer method to change them.
Are all the variables, not all the variables from you. So not all the variables are mutable, and you don't always have to use the pointer to change them, right? So you can say, the normal thing. So this was just like a way of demonstrating syntax, kind of syntax flexibility. Like if you want to change A, like this is how you would change A the normal way. And not everything is mutable. So for example, ABC is not actually, which we'll do later, can't do everything at once. This one is not actually mutable. You're not allowed to change it at all. All right. Okay. So that's this. And again, like if we don't define things, people are not happy that we haven't defined things. As it is, I'm spending the second hour just introducing stuff. Again, more examples as we move later on into the course. So here's how a function works. So this is kind of the typical thing. So this is the return value. So the type of the value that's being returned. In this case, it's int. And then if you have parameters, so our main functions did not have parameters, then you have just a list, and you list the type of each of the inputs. So in this case, each of the inputs is an int, and you also return an int, which a plus b is. So what if a function gets a pointer as the parameter? That's the usual situation in Python if you're thinking back in Python. In C, that's not necessarily going to be the situation, but here's kind of the straightforward example. So here, if you look at the example from before, if I'm saying A42, and then PA is the address of A, and then I'm saying star PA equals 43, so that means that A becomes 42. I could achieve the same thing like so. Should call it 43 really, right? So here what I can say is, okay, I want to call this function. And I want to call it with address of A. So let's first think about, so first of all, what does this do? It does the same thing. So why? So what's happening here is I'm saying I want the address of A. I want to put the address of A in the variable PA. And inside the function, what I'm saying is go to address PA and change the value there to 43. So we'll change the value there. Right? And you can think about it as just like this is the template of how to do it, or we can map it out. So let's look at the execution there. Okay, so A is now 42. And what's happening now is we are sending, just like in Python, sending address of A to PA. So in a way, this is kind of like line 13, except we are setting the local PA here to address of A. So let's do that. Get a little bit smaller. So now once I'm in, what happens is the address of A got sent to PA. So the address of A over here is now over here. So this is the address of A, and this is PA. So when inside of here we're saying star PA equals 43, what does star PA mean? Star PA means go to whatever this thing is. So whatever is the box with that address, and now put 43 in it. Does that make sense? Yeah.
So the first one, functions have to be defined out of the main function.
Yes.
And then this function has to be defined before the main function. We only use it.
So there is like thin distinctions there. So the functions need to be declared, not necessarily defined before the main function.
So that
Let's defer the discussion for later. For now, yeah, you're right that at least with some compilers, probably not with Python Tutor. Didn't actually check. But with some compilers, yes, like you need a declaration, so you need at least the header before you use it. Okay. Yeah, other questions? All right. So, okay. So that was an example of that. The other thing that we need to discuss is how arrays work. So let me go back. I'm going to print this stuff out. So if I declare an array like this, let's say 6, 7, 8. And if I say something like, print it. What this will do is print 6. And that's because when used, array identifiers are converted to the address of the first element. Right, so array by itself is not a pointer to the first element, but when I use it, star array is the same as saying, give me the address of the first element of the array, and then give me the value at that address. So in effect, this is the same. Make sense? Yeah.
Wondering, then how can we just change the first element of the array instead of changing move the whole array to another location?
I mean, I haven't changed anything at all, right? So I'm just accessing the first element, right? So so that's like that. And in fact, in general, A at 0 is basically converted before you do anything to something like this, to star A plus 0, and then plus 0 doesn't change anything. So A at 0, meaning like in ordinary English, get me the first element of the array. Really, it means treat the array as the address of the first element. And then if you do the square bracket, it means go to that address and get me the value there. Okay. So all of that taken together, and that will be the last slide, is basically when you're interpreting things line by line, there are just rules, and the rules look like this. So everything needs to be declared. So far, we saw just, so everything needs to be declared. You put the right-hand side into the left-hand side always. The types are like this, and the types mean that S is of type car star, meaning of type address of car, in the same way that PA is of type int star. And that is why address of A works, because address of A is an address of A, which is an integer. This works because this is how strings specifically work. Array elements, string elements are stored consecutively. So S in this example would be the address where the first element is stored. Array, when used, would be the address where this is stored. And then you can access elements of that are stored in particular addresses using the star notation. So that's all the so that's all the rules. Now, you know, the next couple lectures are going to be about applying the rules, but they are technically all there. Okay, yeah, see ya. Bye. Tomorrow, actually. Yeah. And yeah, so like I said, quizzes, Lightning 180, but not until next week. Yes.
So,
Yeah. Oh, you're there. Yeah, sorry, I didn't get to respond to the email. So yeah, so just email. So I have your email, so I'll respond. Now I will say that it's all a little bit out of my hands, right? So you submitted the petition, I understand, and you heard back about the scheduled exam, so that's what it with when the exam. Sure, yeah, sure, yeah, but like, yeah, like I'll see when I'm free, so I'm free, what do you have today if you want to? It's late. Yeah, okay, you can come in at 3 if you like.
I hope we don't get.
Yeah, but, yeah, anyway, yeah, we can stop, yeah, all right, okay, I'll answer questions outside, yeah.